Welcome to the Technical Writing Success Video Overview by Kurt Robbins, where we help you get smarter than your competition. Today, we're diving into a really fascinating collision of technology and energy, and we're going to ask a critical question. Could a whole new generation of nuclear reactors be the secret ingredient to powering our AI future?
So everything we're breaking down today comes from an article by Kurt Robbins, which was published on LinkedIn back on November 7th, 2025. We're going to dig into the key ideas and really explore what's happening just under the surface of this AI revolution.
Okay, so to really get what's happening here, you first have to grasp the sheer scale of the problem. We hear all the time about AI's hunger for data, but it has an even more fundamental and way thirstier need: electricity. And we're talking a truly staggering amount of it. That phrase right there, insatiable appetite, that's the key. This isn't just, a small bump in energy use. We're talking about a demand so massive that it's forcing the biggest tech companies on the planet to completely rethink their entire energy strategy, right from the ground up. And wow, this slide just lays it all out. On the left, you've got a standard data center rack. It uses about 15, maybe 20 kilowatts. Now, look at the right. A single AI rack, just one, packed with those powerful GPUs it needs, can pull up to 150 kilowatts. That is a nearly 10-fold explosion in power density. It's just incredible. And here's what that looks like when you zoom out to a global scale. We're looking at a projected 165% increase in data center power demand by 2030. This kind of explosive growth is pushing local power grids to their absolute breaking point. And you don't have to take my word for it. This problem has gotten so huge that Microsoft's CEO, Satya Nadella, called energy supply the single biggest bottleneck holding back AI. This isn't some future problem we need to solve down the road. It's the critical challenge of right now. So the obvious question is, why can't we just build more solar panels or wind turbines, right? Well, it turns out AI needs a very specific kind of power, and that brings us to something called the baseload power problem. Here's the catch. AI data centers don't sleep, ever. They are running 24/7, 365, constantly training models and serving up answers. And while renewables like solar and wind are absolutely critical, they're also intermittent. The sun goes down, the wind stops blowing. They just can't provide that constant nonstop power that AI demands. And that constant, always-on power, that's what we call baseload power. You can think of it like the foundational layer of electricity that's always there, always available, no matter what. It's this reliable, around-the-clock energy that AI has to have to function, and it's something the current grid and renewables really struggle to provide at this new, massive scale. So if our traditional power grids are already strained and renewables can't provide that crucial baseload, where does the tech industry turn? Well, the answer is a fascinating piece of tech that, for decades, was almost politically off-limits: small modular reactors. So what in the world is an SMR? First, you gotta erase that picture in your head of those giant, sprawling nuclear plants from the last century. These are a totally new class of reactor. They're smaller, they're built from standardized modules in a factory, and they're designed to be way more cost-effective and much, much faster to build. And what makes these SMRs such a potential game changer for this task? It really comes down to four key features. First is advanced safety. They use what are called passive safety systems that don't need a human to flip a switch, making meltdowns virtually impossible. Second, they're factory built, which just slashes those decade-long construction times of the old plants. Third, they're scalable. You can just add more modules as your data center grows. And finally, and this is a huge one, their small footprint means they can be built right next to the data centers they're powering. All right, so this all sounds great on paper, but is anyone actually doing it? The answer is a huge, resounding yes. The biggest names in AI are making massive, real-world investments in nuclear power as we speak. Let's start with Google. They've signed a world-first deal with an SMR startup called Kairos Power. They're planning to buy the output of up to 7 reactors, with the first plant slated for Tennessee, specifically to get clean, reliable power for their data centers. And Microsoft is just as committed. They've actually hired a principal program manager just for nuclear technology. And get this, in a move that just screams commitment, they've even signed a deal to help restart a stack at the famous 3 Mile Island plant to meet their immediate AI power needs. But maybe the most mind-blowing example of all is OpenAI's Stargate project. We are talking about a $500 billion, 10-gigawatt plan for an AI supercomputer. A project on that scale, you just can't plug it into the regular grid. It is this level of ambition that's pulling the entire tech industry almost inevitably toward nuclear.
So, what does this all mean when you put all the pieces together? What does this massive pivot toward nuclear energy really tell us about the future of AI?
Here it is. This is the key takeaway. We spend so much time focused on algorithms and software, but the next great leap in AI might not come from a coder at all. It may depend entirely on solving this monumental power problem. In the age of AI, energy strategy and technological innovation have basically become the exact same thing. Which leaves us with a really fascinating question to think about. Are we witnessing the dawn of a new atomic age? One that's driven not by geopolitics, but by the computational demands of artificial intelligence. Thank you so much for watching. This is where we help you get smarter than your competition. To stay ahead of the curve, make sure you subscribe to the Technical Writing Success YouTube channel. And if you found this overview valuable, please like, comment, and share. It really helps us reach a wider audience. We'll see you next time.